Welcome students. This is mathematics class for grade 12. Now today's session is matrix that we are doing having part 9. Actually in the book it is given a separate chapter, but it is I have taken it as the part of matrix. So today we are going to discuss about determinants. So in the determinants in your class there is you have to study basically determinants of order 1, order 2 and order 3. In this session I have discussed about order 1 and order 2. In the next video I will be discussing the determinants of order 3. So let us see. You have already studied in class 10 that there are pair of equation in the form of a1x plus b1y plus c1, then a2x plus b2y plus 2. These two are linear equations, so both are called pair of linear equations. Now here a1, b1, c1 and a2, b2, c2 are any real number. That means they are any real number, and x and y are common variable in both the equations. So these two equations can have one solution, any solution or no solution. They all depend on the value of ABCs. That means A1, B1, C1 and A2, B2, C2. So we will see how this value depends. If the line intersect each other, then there is only one solution, and in that case A1 by A2 is not equal to B1 by B2. That means if you find that A1 by A2 is not equal to B1 by B2, then it is called you can understand that there is only one solution. The lines are intersecting each other. In other words, we can write A1 into B1 minus A2 into B1 is not equal to 0. Similarly, if the line coincide means one line overlap another, then A1 by A2 is equal to B1 by B2 and C1 equal to C1 by C2. That means the ratio of all the constant variables, that is the real numbers, are same. And if the lines are parallel, then A1 by A2 will be equal to B1 by B2, but they will not be equal to C1 by C2. So there are three conditions, and on the basis of these three conditions we can determine what type of value will be there or what type of solution will be there for the matrix. So in the first video we have already shown that we have discussed that linear equation can be solved with the help of matrices. So let us see how they can be solved by matrices. Now if there are two linear equations, these linear equations can be represented as matrix in the following form. That means A1, A2, B1, B2, and then this x and y are common, so they are there, and again C1, C2. So we can write a pair of linear equation as in a matrix form as, and whenever we will write in this one, then it is easy for us to solve the equation. We can solve the equation much more easier. Now let us see how we will be doing this. So for we will see step by step what is required. So first let us see what is determinant of first. So what is determinant? If A1 into B2 minus A2 into B1 is not equal to 0, then the system of linear equation has a unique solution. That means the system of linear equation has unique solution, and the number A1 into B2 minus A2 into B1, which determines uniqueness of solution, is associated with the matrix A, and this is called determinant of A, or it is also written as det A, or again determinant of A is written in the pair of straight lines. So if A is equal to A1 B1 A2 B2, then we can write determinant of A as, represent this one, and the value will be A1 B2 minus A2 B2. Okay, so this way we will be you can see here how we are writing this one is multiplied by this one here, and this one is multiplied. So basically we are crossing and multiplying both the numbers. So for this is, but keep in mind, this is for this type of solution or conversion is for order 2 matrix and not for order 3. In order 1 there is only one value, so that is again itself a determinant. So let us check how we can calculate determinant. So determinant of matrix of order 1, if A is equal, A be the matrix of order 1, then determinant of A is defined to be equal to A. Now there is nothing to calculate. If there is one element, there is the same number is the determinant of this matrix. So there is no need to calculation. Or we can write how determinant of A is equal to A. Now something to be noted, for matrix A, here we have used straight line, which we generally use in mathematics as modulus. So don't read it as modulus of A. Instead you will have to read as determinant of A. If A is a simple number or real number, then you can read it as a modulus of A. But if A is a matrix, then you will have to read it as determinant of A and not modulus of A. Secondly, only a square matrix have determinants. That means only a square matrix can have their determinant. If the matrix are rectangular, they will not have any determinant. So determinants of a matrix of order 2. Now let A is equal to, let A be a matrix where there are 4 values, A1, A2, B1, B2. It's a 2 by 2 matrix. Then determinant of A is defined as A is equal to determinant of A, and we also write it as delta here, and that will be just same thing. This is the straight line. See, because the lines, if you are using a square bracket, then it denotes the matrix, and if you use a straight line, then it denotes a determinant. Okay. So the value of this determinant will be A1 B2 into A2 B1. Very easy. So from here we can easily calculate determinant of any matrix of order 2. And I think it is very much clear and easy for you also. So let us see few examples. Find determinant of A if A is equal to this one. Now we have been given a matrix A. So determinant of A will be just this is the representation of this matrix as a determinant, and see this one multiplied minus this one multiplied. So this is 4 and this is 3. So the result is 1. So we see the determinant of the matrix is 1, that is non-zero. So if it is not 0, there will be one and only one solution for that particular matter. What we can say, one and only one solution of the linear equation which is represented. Similarly, now see one more example. If A is y plus 1, y minus 1 and y, then similarly in similar way we will determine y into y, you can see easily, and then this side also you can see easily. Now if you solve y square, here this particular format is in the form of a minus b, a plus b. So the result is a square minus b square. So a square is y square minus b square. Now if we convert, we are getting this knowledge, and this both we cancel and the result will be a. Again this is non-zero. So again this there is only one solution for that particular linear equations pair which this particular matrix is represented. So for today I am keeping that much only, because there is one more determinants we have to calculate, and that is of order 3, but that will take more longer time and it will need more attention. So I have kept it as a separate video. So for today I am keeping this on. Thank you very much for watching this video.